Tutorial is about using SBT for Scala development. I will talk about basic stuff and some frequently seen problems. What is SBT? It is the Scala build tool. It is used to configure the build of your project, to compile your project to run it, to configure how the project is packaged into executables or in library files, the jars. SBT also has an interactive prompt, the REPL, where you can inspect and debug your build configuration. From the prompt, you can run different tasks, such as run tests, compile code, and so on. You can also run a Scala REPL, that is, you can execute Scala statements with your project's class path included. In other words, you can test whether your project works as you think it should. And you can also configure SBT build to publish your software, let's say, to Sonatype open source repository if you wish. The build configuration specifies many things, such as the location for source files. Apparently Mozilla wants to spy on me as well. Thanks, but no thanks. The location of the source files, both for your main code and for your test code. The version of the Scala compiler that you want to use. The options for the Scala compiler, such as optimizations, warning flags, and so on. The Java options, the JVM flags, -x, blah blah, to run or test in different ways. Suppose some tests require a lot more memory than others, then you can configure that, or you can fork a different JVM for certain tests with special options. You also specify the dependencies on third-party library code. You also specify where to download these libraries, the resolvers, the URL for artifactories with those libraries. You specify version overrides. I will talk about this in more detail later. You can also have build steps that generate new source files automatically. You can specify certain options for building your application jars and how and where to publish your final code. A very important thing to understand about SBT is that the configuration, which is usually these three files, uses Scala as the language. So actually Build SBT, Plugins SBT, is Scala code that is put into a Scala object and executed, evaluated. You can have other files, either .scala or .sbt extension in your /project subdirectory, but most likely you would have these three files. Because Build SBT is Scala code, we have many advantages as well as some disadvantages. The advantages are that your configuration is extremely flexible. It is not limited to just building some files and running. You can do anything. A command such as sbt test, it could run tests, but it could also prepare test reports and upload them, let's say, in a spreadsheet format to some online service like Confluence. All of this can be done using Scala, and so you could launch missiles too, if that's some Scala API you would like to use. Also, because we are using Scala we are free to organize that code with best practices. We can refactor so that the build does not have repetitive configuration. We can use third-party libraries, whatever we want, while configuring our build. SBT itself provides a rich standard library for input-output, working with files, directories, processes, or the web. But we can use any other library. So I was not joking about launching missiles or uploading Excel spreadsheets. You can do it in a few lines of code using libraries. Build SBT itself is highlighted by IntelliJ, and you can navigate its code. So you can write your own code, you can write your own libraries just for building. If you want to provide custom settings or tasks, commands for SBT, if you use a lot of different projects that have similar requirements, and you can provide these common settings as the so-called SBT plugins, which is basically a library that SBT will load, just like any other library, but it has certain hooks into the build process. So all of that is possible simply because we're using Scala. But also because we're using Scala, the configuration needs to be compiled first. And how do we configure that compilation? Well, somebody has to configure it. Well, actually it's configured in the same way using SBT. So there's a /project/project where you can have a second build SBT or something. By default, it uses Scala 2.10. You can change that with the newer version of SBT, but I don't recommend using it so far. Because of this, the build is slower. You need additional compilation steps just to compile the configuration. Also, if you have any errors in build SBT, such as incorrect type, that's going to be harder to debug because IntelliJ won't be able to load anything. It won't be able to highlight anything if build SBT has an error. The entire project cannot load. So you would have to debug this at the command line, which is a bit harder. Fortunately, build SBT usually is a very simple code. Another disadvantage is that there are a lot of functions, conventions, and different operators in SBT. It provides a DSL, a domain-specific language, which has a steep learning curve. For example, look at this line. This is a line typical in build SBT. It has lots of operators like in, something in something, tilde equals, and then some stuff. So all that needs to be learned. The only way to learn this is by example. There's just too many things to learn, and you just cut and paste a lot of code from Stack Overflow and see if that works. As long as you copy from similar projects or from sources that really solve your problem, that's fine. Build SBT is a very simple program, and it should not be overly complicated. So the main way of configuring is using settings and tasks. Settings are values that you set, such as Scala version. That would be, for instance, 2.12.4, and that's a string. So you see this is a setting key of type string. Everything is typed since this is Scala, so errors are avoided. Publish artifact. This is a Boolean key, so this is false, then this artifact will not be published. Library dependencies. This is a sequence of module IDs. We'll look at this later. Basically, it's a sequence of library names and versions. So these are settings, and these are commands like compile, package bin, so that's binary packaging, doc, that means compile the documentation. The result of that is a file. The result of that is a file. This is analysis. So this is some internal stuff. These are commands. For example, you would say SBT compile. Let me show you here, for example. Here I'm in a project, and I will say SBT compile. So this is a command, and it will load the configuration. Right now it's loading the configuration, compiling it. It has compiled. Now it's resolving my libraries. Okay, now it's saying loading project definition. So right now it's compiling it and running actually build SBT. Nothing is yet compiled from your own code. Right now it's only build SBT that's being compiled. Okay, done. So now it knows what to compile in your own code. So this is my own code, only now it started to compile that code. So you see, there was quite a delay before the actual compilation of your code has started. Because first you have to compile build SBT itself, the file, which is Scala code as well. So you have to understand there's this step, and every time you run build SBT, the step is going to run. Now there's a lot of compile warnings here. Let me kill this. Another way of cutting that time would be first to start SBT like this without any commands. Then it will load its configuration. So first you see it loads the project, and now I can say compile, and it will compile my Scala source. So now it's much faster to say compile. Now if I want to recompile, it will be faster. So that is a good way of dealing with build SBT, that it is slower. So let me go over basic things. The first file you usually make for a new project is this, build.properties, in the project subdirectory. And here's what I would put in there. This is the latest stable version of SBT that I would recommend. The actual latest version today is this, but I wouldn't use it. I had trouble in various situations. I had trouble using it, and I'll wait a little more until SBT matures in its latest version. For a single project build, the build SBT file can be very simple. This is the entire build SBT. It could configure some project. You see it sets Scala version using this syntax, cross Scala versions, name of the application, version of the application, and library dependencies. This is sufficient if you just have a single command line application or graphical application or maybe web server application. It just runs and has some library dependencies. If you have build SBT and project build properties like this, that's sufficient to get started for your project. Once you run SBT, these are the directories it expects to find. So /target are directories created automatically by SBT whenever it compiles something. So everything that's compiled is into target. Also, generated sources are under target. So when you say SBT clean, it will delete all the target subdirectories that were created. The first target subdirectory actually is in /project. And that is because, as I said, build SBT itself has to be compiled, and the result of that compilation is under project/target. Now, the main code of your application is under src in current directory, main /scala or /resources that are resource files. And the test code is under src/test /scala or /resources. So this is the default layout that it expects, and the standard way that most people configure their builds is this. It can be changed, but that you just need to write more stuff in your build SBT, and you will confuse other people. This is the convention today. Now, consider another example when your project has many subprojects. So your build has an application, a library that it's using at the same time, and some kind of client library or application. So you want to publish 3 different jars, let's say. Application jar for this, the library jar for other people to use, and a client jar for other people to use. This is how you would configure it. First, you would have a value with common settings, because otherwise you would have to repeat this in every subproject. So you put this, just a sequence of these. These are values. You see, these are not some kind of magical commands. This is actually a value, a Scala value with a type, which you can put into a sequence and assign to a val. There's no special magic right now. The colon equals is an operator on a class, so it's just a value. Everything here is a value. This is a project. It's a value as well. It needs to be lazy, so just keep in mind all project values must be lazy, otherwise it won't work. The SBT library requires you to do that. So here's I define the project in file. So this is a directory where the source files are going to be. So for example, my app is a project in file my app. So that's actually directory where the sources are going to be for this subproject. So I keep saying subproject on purpose. It's less confusing this way. So all these things are subprojects in your build SBT. Hello root is a subproject. Right now, I just said it was publish artifact false. So this actually is not going to have any code or publish any jar. It's just going to aggregate other subprojects. The reason people do this is then it's much easier to run everything. For instance, SBT test will run tests on this project because it's the root. It takes the project associated with the current directory as the root. So SBT test runs test on the root, and that aggregates these 3. So this will run SBT test on all 3. So then you don't have to remember to run tests on each of these projects separately, which you can, but if you just say SBT test, it will run tests on everything. If you see SBT compile, it will run compile on everything that's aggregated. Publish everything that's aggregated. So that's just convenient. If you have many subprojects, you make a root subproject that doesn't have any code, doesn't publish any jars, it just aggregates other subprojects. And here are your subprojects. Settings, and then you have, so dot settings is what you say, and then you can write version equals name equals library dependencies equals, and then look at how I'm using this common. Common is just a sequence, so I just put that in here, and that works just as if I wrote these 3 lines in here after this settings. So in this way I can reduce repetition in my configuration and make it cleaner. So finally, the client is similar. So each of these subprojects can have different settings, different library dependencies, even different Scala versions or options for compiling. Now also look what happens here. There's depends on. So this subproject depends on library. So application depends on the library, and client also depends on the library. Library doesn't depend on anybody. So this is a typical layout. So I have common code in the library, and both server and client, let's say, depend on this code. So my app is the server, let's say. The jar for it will be this name, because I declared the Scala version to be 212. So the jar name will be my app, which is this name, which is actually jar name. This name is just jar name. My app underscore 212 dash 100. 100 is this version. This is a string. It can be anything. It can be blah blah dot jar. And similarly, client subproject will publish this jar, and library subproject will publish this jar. And then if you do this build SBT, then this is your expected directory layout. The subproject must be in directories my app, my client, and my lib. So look at the definitions. Project in file mylib. You see, this is the directory name for the sources, not my dash lib, not my underscore lib. It is this, in which file it is. And for each of these subprojects, you would have an SRC source with main and test and target. So all the files compiled for each project will be in /target. There will also be /target in the root. It will be mostly empty, just a couple of files perhaps. Make sure you put the target subdirectories in your git ignore if you use git, otherwise you end up with all those files. And just as a note, if you have Java code together with Scala, then you just say src main Java and you put it there. Java files will be compiled together with Scala then in the same jar. So it's completely transparent, very easy to use Java source code together with Scala. What is the project's plugin SBT? This is actually relevant to the configuration that needs to compile your build SBT. So these are the SBT plugins that you use, the libraries that you need. So plugins SBT can also have library dependencies. It's like a project, except it describes the compilation of your main build SBT. So the libraries that you list as library dependencies are those that you need while compiling your code. So such as source code generation, like protobuf, database source generation, something like that. Also, artifactory resolvers can be configured in plugins SBT, and those will be used to resolve plugins and libraries for compiling build SBT. So just keep in mind, there are two compilation steps when you do SBT-based development. The first step is to compile build SBT itself, the file build SBT. And the second step is to run the code that was obtained from that first step. And that code, when run, will compile your main application or library code. So the basic tasks in SBT are these. Update will just verify and download all your dependencies. Let's look at that. So I can say update. It will, as you see, it will resolve various library dependencies and verify that they are all current. Download if necessary. Compile will compile your main code. Test::compile will compile your test code, but your test code always depends on the main code. So actually it will compile both. The compilation is incremental. So if some files did not change, it will not compile them again. This is sometimes a problem, especially with Git. Sometimes you check out a different branch, nothing has changed, but it wants to recompile everything, or vice versa. In some cases, you need to recompile, even though the code did not change, because something else changed, some options changed, and you want to now recompile with new options. And SBT usually knows about this, but sometimes it does not. Run is to run the main method of your app object, so this will be for command line applications. Test will run all the unit tests. Publish local is a useful command for debugging when you debug libraries. If you provide a library, then you want to publish your library locally, which is to your own local repository of jars, which is here. And then a different project wants to use that new version, the development version of your library that you just published, and test that it works correctly. So that's the usual way to do development of a library. Make sure that it can be used by different other projects. Publish signed means that you sign your jar cryptographically and publish it to some artifactory. This requires additional setup, which I'm not going to describe. You have to read documentation for Sonatype plugin or PGP plugin. Just cut and paste from their documentation and you'll be fine. SBT assembly is a plugin that packages the application jar, a very useful plugin. And clean is the command that will delete all the compiled and generated files so that you can start clean. And that is useful in cases the incremental compile is wrong. You need to clean up stuff, and so then you do SBT clean compile. You can combine these commands. For example, you can say SBT clean update compile test compile like this. So the basic settings, most important ones, are Scala version, Scala C settings. These are the settings of your Scala C compiler. Dependencies and libraries, which are these keywords or functions. And names for your jar artifacts and where to publish them. The version, name, publish to. These describe the publishing of your jars that you compile if you need to publish them. The settings can be specific to a subproject. So here's an example of SBT code that can take a while to get used to. So you see, on the right-hand side of these special operators of the colon equals, plus equals, and so on the right-hand side, these things are not available as their values unless you say dot value. So you have to say dot value, and then version or library dependencies or Scala version will be available if you say dot value. And then you can also say version in my subproject. So for example, in that case of library, you would say version in my underscore lib. And that will give you the version defined in that project. I remind you, each project would have its own version. So for example, or name or anything. For example, you say name in my lib. That will be this. And name in my app would be that. However, you can only use this at the right-hand side of an operator such as colon equals or plus equals. On the left-hand side or in ordinary code, you cannot use that because these are not values. The version itself is not the string. It's a special key that can be specific to different situations, different values in different projects, and so on. It can be even different value during run, during compile, or during test. So make sure you understand this before you start writing more complicated code, but usually people don't need to write that kind of complicated code. All these settings are evaluated when tasks are run on a project. So they're all lazy in some sense, and the semantics of this is similar to assignments. So that's why this operator was chosen. So for example, if you do this, then actually this will be the value. But it will still evaluate this code. So you could have here a side effect. It will be evaluated. So that's a bit of maybe too much to understand for now. Basically, you just take examples and start from there. So take this as an example. Let me actually show you an open source project. Okay, so here's one with very similar structure. So I have a root aggregating project which aggregates example 01, example 02. And then these are projects with Scala version defined. I was too lazy to do common here. And then library dependencies are just Scala test. And I was very lazy with this project. It's just a test. Here's a Oops, what is this? I wanted to show you a different project. Oh yeah, it's right here. So this is my chemist project, which has a more complicated build SBT. So let me just walk through it perhaps quickly. So there are a lot of common settings, as you see. So this is coming from the plugin. I can option click on this and navigate to the source code of SBT. And then I can see if I somehow need to see what's happening, what kind of settings are default, core default, or I have full source code available. So organization, version, this is relevant for publishing. Cross Scala versions is relevant if I want to publish my library with different Scala versions. Then I would say cross Scala versions is this, and then I would say SBT, SBT clean plus publish local, for example. If I say this with the plus, then the only difference between this and this is that the plus will take a look at my cross Scala versions here and publish first with this version and then with this version. That's all. And I could do this by hand as well. If I said plus plus 210 211 whatever 11 publish local plus plus 212 4 publish local. I could do this too. This is exactly similar, exactly equivalent. With plus plus, I can enforce Scala version on the next commands, and then I can enforce another Scala version on the next commands. So this is what I do with my library because I want to publish it with Scala 2.11 and with Scala 2.12. Resolvers. So these are resolver things that I need. Well, probably I need fewer than this, but doesn't hurt. Licenses, homepage, this is all for publishing. These are not needed. Scala C options, these are the options for the Scala compiler. It's a sequence of strings. So I look at various people and how they, like this is Rob Norris, I believe, who has some web page about what flags he likes. So I looked at that, I looked at other people's flags. So anyway, and then I have some code that decides what flags to use depending on Scala version. So you see, because this is Scala code, this can be just arbitrary Scala code. And I'm going to use these Scala C options later. But now I'm computing. This is just a val, you see? Val common settings. So I can just compute this val initially and then use it later. So then there are some more options for the various debugging usages. This is a command to use the tutorial plugin. I just cut and pasted this into my build SBT. I don't really know what this does, but it's activating the tutorial plugin in some way, so that's good enough for me. Then I have this root project called build all, because it aggregates everything, and so it's a root project because it's in the root directory of my project. So this is how you see there's no annotation on it that this is the root subproject. This is automatic since it's in the root directory. And then I have common settings in it, and then I have specific settings for root, and then I disable certain plugins because I don't want to create assembly jar. This is actually not necessary, I believe. This line, I copied and pasted it from somewhere, but I don't believe it's necessary actually. Let me delete it. Alright, so this is a second subproject which is called core. In the file core, now you see my IntelliJ shows me main, Scala, and then there's my package, and then there's my source files, and tests. Tests have resources, and then some tests here. It's test slash Scala slash whatever, package, as usual. And I have settings, I have library dependencies. Here's how library dependencies are declared. See all these symbols help us declare library dependencies in some way. So I commented some of them out. It's a Scala code, so you can use ordinary Scala conventions for everything. And again, I disable assembly plugin. Benchmarks. So benchmarks is a special project which I use to run some stress tests. So this is forked in different, actually not forked, but it could be forked, and it would have different Scala options, Java options, and different flight recorder. These are debugging options. Here is a custom command which I use to run the project with a profiler. And here are some settings for publishing. So this is fully cut and paste here. I don't really know much about what these things do. Publish maven style is some important thing apparently that makes POM files. Anyway, cut and paste here. All right, let me go back to my slide. So that was an illustration of typical build SBT. So let me go on to another topic, which is how do you deal with libraries, dependencies, and jar files. So first of all, a jar file is just a zip file with some extra metadata and possibly a cryptographic signature. There are 5 kinds of jar files that I could think about. One is application jar. It has all dependencies included, and it can be run with this command because it has a main method. A library jar has no main method, so you cannot run it. It has only the classes of the library in it and no dependencies. There are also library jars that do have third-party dependencies included in the jar, and that's a bad idea. It gives you a lot of trouble sometimes. An example of this library is Mockito-all. Know this from first-hand experience. Problems. I will explain why. Source jar, it has Java or Scala files, source files only. And finally, documentation jar, which is HTML files with documentation. A library jar typically contains these kinds of files. It has Java class files, .class, resource files such as config files or data files, and some build time information, licenses, whatever, other files. You can just unzip the jar or list the contents of a jar and you will see. So for example, you'll see a file structure like this. You have meta-inf manifest mf, which is required, text file that describes some stuff. And then you have this, you see maven org javalution. This is junk. You don't need these files, but they are in your jar because some library put them there. They're not really necessary for your application. These are actual code files. So you see class is a compiled Java class, and the path name reflects the package of the class. So for example, this kind of path, so directory org, Apache, Zookeeper, and so on, this would correspond to a Java class that you import using this syntax. Import org, Apache, Zookeeper, and so on. So all the class files and all the packages are just unpacked here in this big zip file. And that's the jar. That's what the jar is. So in order to assemble an application jar, here's what needs to be done. First, you compile all application code files into class files. So you get a bunch of class files in directories like this. You need to download all the library jars you need, unpack them. You need to copy all the resource files that you have, like for instance, if you have a resource directory, blah, and the resource file in it, then you have to copy this into blah/file in the root of what will be the jar archive. You also copy all the resource files from library jars. Then you gather all these unpacked files under one directory. So all the files from all the libraries will be in one directory. Obviously, there can be conflicts. What if a library has a resource called config.xml and another library also has config.xml? What do? You cannot have two different files with the same name because they're in the same directory. So that's called a deduplication conflict. So that needs to be resolved somehow. One of these files have to go, or they have to be merged somehow into one file. You need to add this meta-inf manifest, and then you need to zip everything into one big jar file. So all of this work is done automatically when you do assembly. And then the assembly plugin allows you to specify deduplication rules manually. Let me illustrate the library dependencies of a project. So most times nowadays people use open source libraries, and with open source libraries the good thing is that IntelliJ will be able to download the sources and navigate through them. So here's an example. I'm using some open source library. Let's see which ones. So for example, I'm using Scala. I'm using standard library as well. I can just click on the function and I'm navigating into the jar file of this library. Now you see this is a source jar. I have a documentation jar and I have the binary library jar. Since I have all these jars, since this is an open source library, I can navigate everything in the source code of the library. Notice the structure of the jar file. There's meta-inf with manifest, which has this information. I don't know what it is. Necessarily, I don't care. And there's some files here under the streams package. So this is a typical thing that a jar would have. In IntelliJ, you can go to your project's external library section. Here is the external libraries. And then you see all the libraries that you need. Now, there are many more than I have in my Build SBT. If you see my Build SBT, you see the green strings, or Scala test, Ammonite ops. This is just for testing, but still I have just a few dependencies here. Guava, Scala reflect, Scala compiler, Scala plot is only for testing. Just a few dependencies, right? And see how many libraries I got here, which I didn't mention. And these are transitive dependencies. So for example, this depends on that. Guava depends on this. So SBT will download and use all those libraries that are necessary. So if you depend on some library, and that library depends on 10 others, and these 10 others depend on 100 further libraries, all of these libraries will be downloaded, and they will be all here on the left pane, and you can open them. For example, iText PDF. That's it. That's your library. You can open. These are Java files. You can click on them and see the source code. You can even set breakpoints into that code and debug it in IntelliJ. That's how powerful it is to use open source libraries. Another thing I just wanted to mention is that when you make changes to Build SBT, you need to refresh your project. I just made a change. Previously, it was telling me that I should refresh. I made another change. I did not refresh because I knew I was making more changes. I don't want to refresh every time. Refreshing takes a while. It needs to download again various things, maybe not. Enable auto import is something I do not recommend doing. It will then refresh every time you touch Build SBT, even if you add a space to it. There will be a change, it will have to refresh, and now I'll refresh now, I'll see what happens. First, it compiles my plugins SBT. Then it finds how to compile Build SBT. Then, and that's not done yet, I believe. Once that is done, it will compile Build SBT. And once that is done, it will start. Okay, so now it's getting my libraries to compile Build SBT. So only now it is done. Hasn't even started with my code, just compiling Build SBT right now, the /project. So this is what it means, loading project definition. It compiles my Build SBT right now. So you see, it takes a while. So that's why don't do enable auto import and refresh your project when you need it, not automatically every second. You just waste a lot of time. So now it's checking my actual dependencies of my code. And once that's all done, it will re-index. And once that's done, your project is refreshed. So now two processes are running. These are re-index processes. You can always refresh your project even if it doesn't ask you to. You can press on this SBT button on the right, and then you press this. This will refresh all your projects. Also, these are subprojects. You see, each one has a build, because build is the project that compiles Build SBT, and that's also configured and it needs to be refreshed. Anyway, you can do that at any time, so don't do auto import and don't refresh every time automatically. Refresh by hand when you need it. Let me go back to my slides. So there are two kinds of dependencies. One is library dependencies, and the other is inter-project dependencies. That is, one subproject depends on another subproject in the same Build SBT. So the main difference is that library dependencies are downloaded from some artifactories, which is file repository, such as Maven Central Repository. And you need to specify version of the library that you want. So either you specify a particular version exactly or a range of versions. And that needs to download from Artifactory. It will put the download into your local cache. If it's already there, it doesn't have to download. Subproject dependencies means that one subproject depends on another, and they always depend on the current version. There's no way to specify older version of that dependency. It does not use Artifactory or local cache when you do this. It always depends on live code in that subproject. And finally, both subprojects need to be published with the same version always if you do subproject dependencies. This is an important consideration. Dependent and depending subprojects. So if A dot depends on B, then A and B must have the same version when you publish them. Otherwise, things will just not work because of this property that subprojects always depend on the current version of each other. So So when do you use one or the other? If you have a lot of code that is changing fast, you have a library and a server that's using the library and the client that's using the library, and they're all evolving very fast, then you should do subproject dependencies and keep them in one project. It will just be much faster to develop. If you don't do this, you would have to first change the library, publish it, change the version, and then make the change in the other subprojects to depend on the new version of this library. This makes development slower. So while the code is actively developed together, so server together with client, together with library, something like this, you should use subproject dependencies and keep all code in one project. Once libraries become stable, or if you have completely unrelated code that's not going to be developed together, or going to be developed independently by different people, then you should put this in different repositories, publish them, and use library dependencies. So one would depend on the other as a library published on some artifactory. There are two kinds of library dependencies. Managed libraries, which you specify using this library dependencies equals, or unmanaged jars, which are in the lib subdirectory. I can show you that. This project has a lib subdirectory, which contains some jars, which are unmanaged. So you put them there yourself, and SBT doesn't know about them. So it's your responsibility to manage these jars. Whatever is in the lib is available. You can import it and use it, as I just showed. But SBT doesn't know about it, and if there are any conflicts, you will have to resolve them yourself manually. You have to know what you're doing when you do the lib. One use case for using unmanaged jars is when you have a library you compiled yourself just for development purposes. Not stable, like this is a snapshot. It's not a stable version, it's not published anywhere, and you just want to try something quickly. That's fine then. Or there's a library that's kind of old and it's really not published anywhere, and you don't care to touch it. You will never touch it. It has some functions you are going to use. You'll never touch that, so that's probably fine to have. But it's better to have published dependencies, because then you don't have to deal with these files and they're maintained better. So how do you find what versions are available? Well, you look at the official Maven site, which is maven.org. The central repository provides you search. So then, for example, I want to find out what is the last version of my library, which is Chemist Core. It tells me it has 017 of this, and it has 020 of this. So this is how you should discover what versions you want. Now, how do I know what versions I want? Well, I look at the all version list. I see that 020 was published in June, 019 in May, 018 in March. So since June there wasn't any new version. So probably this is okay version to use, because if there were some bad bugs, they would be fixed probably within a week or two. Apparently this is working fine. So let's use 020. That's the kind of reasoning you want to do. Do not use this site called MVN repository. Now, why am I saying this? It's because you say here Maven repository, right? You don't know where to go, you forgot the URL. And what do you see here? What's the first one that comes after the ad? Is this Maven repository. Yes, this is not what you want. 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 What you want is maven.org. That company, it's some commercial company that has nothing to do with maven.org. They have an outdated version of the database. They will give you more information but you don't need that information, and don't use them. Use official Maven site only. Search maven.org. So once you determined which version you want, with Scala to 11 or Scala to 12, add your dependency to your project settings like this. Library dependencies, so plus plus equals is a special operator that takes a sequence, very convenient to use, so then you have all your dependencies in one place as a sequence. The special operators double % is for Scala dependencies and single % is for Java dependencies. This is because this double % inserts a Scala version binary suffix. So the test code versus main code requires you to think about what libraries are necessary for main code and what libraries are necessary for test code. And if you look at typical library dependencies, then the test library is marked like this. Now this is called a classifier, and in most cases either you have no classifier, which means it's for the main code, or you have a test classifier, which is for test code. Now it's important that you add the test classifier for test code, otherwise other people who will depend on your code will be obliged to also download your test library dependencies, which they may not need. So usually tests are not shared between projects and not published. If necessary, for some reason, you can publish a certain special kind of jar called a test jar, which is like a library jar, but it contains your unit tests. Now consider this, each library also has its own main code and its own test code. So in principle there are 4 possibilities. Our main code depends on the library's main code. Our test code depends on the library's main code. Our test code depends on the library's test code, and our main code depends on the library's test code. Now the last 2 possibilities should be avoided. Why? You shouldn't depend on other people's test code. It's their test code. Usually it's going to be very unstable, and it's not necessary in most cases. If you need common test utilities, you can very easily make that a separate library project whose main code will be the test utilities, and you will depend on the main code of that library for your tests, which is case 2. So there's no need usually to depend on test code of other projects. There are some rare cases when this can be okay. In most cases this is not okay. So make sure your test dependencies are marked with test. You can do complicated things like this, which means you want both the main code depends on their main code and your test code depends on their test code. But in most cases that will not be necessary. Let me now discuss the thing called the jar hell. The situation called the jar hell means that something went wrong with dependencies. Your code compiles, but it does not run because it cannot find some class or method. Or code compiles, tests run, but you cannot assemble the application jar because of some deduplication errors. Or code compiles, tests run, but the assembled application jar does not run. Again, there are some errors such as cannot find some class or some method. This is hard to diagnose because your code compiles. There are no errors until you start running something. The most frequent reason for this is that there are some transitive dependencies that declare some incompatible versions of the same library. SBT will choose the latest of these versions and it will ignore other versions. And usually this happens when you don't even know that this library is on your class path, that somebody depends on this library. You don't know about that library. And in that library some changes occurred and the code doesn't know about it. So that's a bad situation. You should use dependency overrides or exclude directives, and then maybe you can use a non-latest version, or you can evict or exclude other versions. Here's an example. Suppose that you have dependency on library A and library B in your code. But actually library B and library A both depend on some library X. However, A depends on this library X version 1.0.0, and the B depends on library X version 1.1.0. And then there is a breaking change, which people didn't actually expect to be breaking. For example, here 1.0.0, it defines this method, and 1.1.0 defines instead this method. At first sight, that's not a breaking change, because you can use the method with one parameter since you have a default value for the second parameter. But actually, this is a breaking change at the Java level, because this is a Scala thing, this default value. It doesn't exist on the Java level. What happened in the Java is that this method disappeared with one parameter, and this method appeared with two parameters. So library A depends on this method. It tries to call it at the Java level, because ultimately everything is compiled to the Java code, bytecode, and it can't find it. However, at compile time, the library is already compiled and its tests passed. It doesn't know that you're going to evict 1.0.0 in some third project that happens to depend on library A and library B. And you don't even know about the existence of library X. You never heard of it until you see this very strange error message that the method you never heard of in some library cannot be found. Same can happen with classes that disappeared. Basically, your code or the code in library A may have to be changed to fix this. This is not easy to fix, and it's not even easy to figure out why this happens. So there's a very useful plugin called dependency graph, where you can have commands such as what depends on this, and then you see what libraries depend on this. Or you can do this command. I recommend redirecting the output to a file because the output is very long and very repetitive. So I'm still looking for ways of getting the dependency graph to be less repetitive, but so far that's what you need to do. So dependency graph will show you all transitive dependencies of all the libraries that want to depend on what versions of what other libraries, and you could figure out that this kind of thing happened and diagnose your jar hell. Other reasons is that less frequently a library jar contains classes from third libraries. An example of this is slf4j over log4j that contains some of the same classes as log4j, Apache log4j, or Mockito all, it contains its dependencies, Hemcrest core and obgenesis. It actually doesn't say to the build system, but it contains these classes. So silently, when you depend on this library, you also depend on this at a specific version. And that can lead to problems like those, like methods that are disappearing or evicted. You might depend on libraries that are incompatible, but you don't even need these libraries, but still they're there because of transitive dependency. You need to exclude and make sure you exclude the right things that you don't need, exclude the right versions, or exclude all dependencies of certain library, any version. You have to be persistent until you figure it out. So there's a documentation link to encode, to exclude transitive dependencies. Read this to understand how that works. Finally, there's a very rare situation, but it still happens, that some library has changed its name, not only its version, but it's the same library. Here's an example I saw recently. There's a library called Woodstock Score, and it used to be called Woodstock Score ASL at version 4, and now it's Woodstock Score without ASL at version 5. So, because the name has changed, the build system doesn't know that it's the same library. The build system, your SBT, thinks that these are two completely unrelated libraries, and so they can be both in your project. And of course, that's a big problem because they contain the same classes mostly with different contents. There's a plugin called SBT Duplicates Finder, which discovers this situation, that you have Java classes on your class path that have the same name but different contents, which is usually a sign of trouble. At least when you try to assemble application jars, that would be impossible because of all these incompatible duplicate classes. So you need to use exclude directive in your dependencies. So take a look at that in the documentation when you need it. Finally, to diagnose what's happening, you can go through your, if you can't find the class that is problematic, you get an error such as method doesn't exist or class duplicate is incompatible. You have no idea what is coming from. You can't figure it out using a duplicates finder or a dependency graph. Go to your IV2 cache and find out which jars have these classes. Basically, just do a find command in bash to find all the jars, and for each jar, do an unzip -l and grep for the file names that you want. You'll find the jars, and then you can drop these jars into IntelliJ, like I dropped those jars into the lib I just showed. And you can this decompiles on the fly. You can just, even if you don't have the sources, it will decompile your classes and show you the source code. Decompiled class file, you see that? So it can decompile jars on the fly and show you the source code. So then you can verify which classes have been problematic. What are the methods that disappeared or classes that disappeared? And then this is relevant for assembling the application jar. For each of these classes, you need to figure out how to exclude properly, or maybe dependency override, or maybe merge strategy as last resort. So to summarize, what happens is that somewhere in your jar structure, which I'm going to show you again here, somewhere here in your jar structure, there are classes that have the same name, the same path, same package, same name, but are coming from different jars, from different libraries. They have to be unpacked at the same location. This is how jars are designed. They cannot be coexisting, so there can be only one class called abstract context in the package javalution.context. If there are two libraries that contain this class for any reason on your class path, and you're trying to assemble the jar, or you're trying to just run it, only one of these classes is going to be used. When you do SBT run, or you run tests, then one of them is chosen in some way, usually non-deterministically, arbitrarily. It might fail because it's not the right one. But it might not fail, your test might actually pass. But once you start assembling the application jar, there will be a problem because there will be a conflict. Two different libraries will want to put this exact file name into your jar. Then you need to specify the deduplication strategy. This could be as simple as discard, just ignore all of these classes. Maybe you don't need this class. Maybe this is in the library, but you never call it. So you can just discard it. Or it can be more sophisticated. It can be first, last, but none of this is sure and foolproof. The best would be to figure out the exclusion. Exclusion would work like this. Let me just demonstrate. If I wanted to exclude something from here, then I would exclude org Apache zookeeper, for example. This may not be very helpful for my project. Probably Google's Guava does not depend on Zookeeper, but if it did and it caused me trouble, I would do that. Let me undo this change. To summarize, what are my general recommendations for using SBT? Organize your project using many subprojects. Logically split into library, server, client. You can have many libraries. There's absolutely no penalty on having different subprojects. It's very easy. It makes things faster. You can run only one subproject's code, for example. Here's how you would do this. SBT. Then I would say there's a core subproject or a benchmark subproject. For example, I can just run the compile for the core. Let's say core compile. And this only runs compile for the core. You see, it's already compiled, so there's nothing to do. I can do core clean. It will not touch the benchmarks project, only do the work for the core project. So this can be faster. Core compile. It's just compiling the sources for the core and nothing else. So this can be faster if you split your project into a number of libraries, modules that are very small maybe, or larger, but logically in some way. There should not be any circular dependencies between subprojects. That's important. So that also helps you organize your code better. Then you create some aggregator subprojects to control your builds, such as all your Scala code or all your Java code or something. I showed you an example of an aggregator. Use common settings and vals, reuse them in subprojects. And if you have a lot of common settings for different builds, make libraries. Use SBT as software. Make libraries and reuse code. You can easily reuse SBT code between projects. You can, for example, Scala C options. If you use the same options in 5 or 6 of your different repositories, make an SBT plugin with these options, publish it. Even if you publish it locally, that's good enough. There are very useful SBT plugins such as Scala Style, Scala Coverage, Dependency Graph, Duplicates Finder, Word Remover, and Acyclic. Explore them. They're all open source, easy to use. Cut and paste code into your build SBT and try it out. And finally, to speed up your work with SBT, can be quite slow. If you don't do this, start SBT and do not quit the session. Work within the same SBT session. It's much faster than starting SBT each time. See this, for example, core clean. It does not have to reload everything again. It does not have to recompile everything again, refresh. It's much faster. Here, when build SBT changes, you need to do reload. You don't need to quit your session and start SBT again. You just do interactive testing. You can do test only to run just one test. You can do switch to a project, or you can run with a specific project. So here, for example, project core. Now I've switched to the core project. Now I can just do clean, and it will be the same as core clean. I can do test compile, and that will be the same as core/test compile because I'm switching to the core project. So do that, and you will find that your working with SBT is faster and you are more productive.